All right. Good morning, guys. I hope you're doing well today. I know that it's early and it's a snow day, and you guys are hoping to move on and do your own thing today. It's not really a fun thing to do schoolwork from home, so I'll try and make this quick for you guys. We are going to be working on what we worked on yesterday. We did problem one, and I said that there were going to be three more. I actually cut it down to two so that this goes quicker, it's easier for you guys, and you're going to be able to fill this in as we do it together in this video. All right, so I'm going to be like handing you guys the answers, fill it in as we go. I'm not so much worried about you guys being able to do the math as you are seeing that there's a process to getting these numbers, that we're fairly certain that they're accurate for various reasons, and mostly that you guys can see like, oh, it takes that long to get to Mars. Like that's what we're going to be studying in the first one. Oh, you have to bring that much food if there's that many people on board, right? And then you start thinking about, oh, well, we have to bring that much food, then we need that much more room on the spaceship. And if we need more room, that's going to take more fuel. If we need more fuel, that's going to be more expensive. It's going to take longer to like fund that mission, and that's why it takes so long to get to Mars and all those different things. Um, just to kind of get you guys thinking about everything that goes into space travel because it gets really complex. That's why we have NASA, which hires hundreds, thousands of people to do this work. So we're going to do some of the smaller bits of this, and we're going to do it together. All right. So step two, since we did step one yesterday, is how long will it take to reach Mars? All right, it says since our final speed is 7 miles per second, remember that's what we determined yesterday, that's how fast you have to be going to leave orbit. As we leave orbit, how long would it take to reach Mars? Remember that there's no resistance in space, so we neither increase or decrease our speed the whole way. And that's different from on Earth, right? If I get in the car and I'm going, 60 miles an hour down the highway and I stop pressing on the gas or I take the cruise control off, I'm going to start slowing down and make the people behind me pretty upset. Yeah? All right, well, it's different for, space shuttles. They're out in space. There's no road, there's no wheels, there's no air in the way. Everything's just this big giant vacuum. And so as you're moving along, nothing slows you down pretty much at all. So unless you needed to change direction for some reason, if you leave at 7 miles per second, you're going to stay at 7 miles per second until you choose to change direction, slow down, whatever. All right, so the first step here is to Google how far away Mars is from Earth. And I'm just going to give this one to you guys. You can look it up if you want, but you take the averages of this is how far Earth is from the sun, this is how far Mars is from the sun. It's going to be about 49 million miles. All right, and write it out with all the zeros. Don't just write it in millions or billions. All right, that's important because we're going to use it right down here in just a second. All right, but we forgot something. We have to make our text a different color so that when I'm looking through this, I can say, yeah, you filled in that blank, you filled in that blank, you filled in that blank, and I'm not going to miss it by accident. Try to look pretty carefully, but anything that you can do to make sure you get these points, it's probably a good thing. All right, so instead of retyping that number, I'm going to bring it down here. Now I'm bringing it down here because if we travel at 7 miles per second, then we use the following equation first to find out how many seconds there are to Mars. Now, I don't know about you, but when somebody asks me, hey, how far is it to your house? I'm not telling them, like, oh, it's 724 seconds if you're going the speed limit, but less than that if you're going faster. I don't do that. I'm generally going to tell them, hey, this many minutes or this many hours. If it's to Indy, it's maybe an hour. If it's, from Bloomington to Brown County, maybe it's 20, 25 minutes, right? So we need to find appropriate units. But since we had it in seconds, we're going to be continuing to use seconds since we're traveling in miles per second down here. All right, so 49 million divided by 7. We're going to pull up our calculator, clear it if you got anything in there, and 49 million divided by 7 is going to be 7 million. That is a really nice number. All right, so we're going to change that color again and keep on rolling. So 7 million seconds to Mars. I don't know about you, I have no idea how long that actually is. So we're going to turn that into a usable number, right? So we have 7 million seconds, and we want to turn that into minutes. All right, well, there's 60 seconds in a minute, so if we divide this number 7 million by 60, we'll get how many minutes there are. So we'll pull up our calculator again, we'll divide it by 60, and we'll get 116,667 minutes. 116,667 minutes. Again, I have no idea how long that actually is. That's kind of a meaningless number to me. Generally don't think of minutes further than like, about 120 since that's 2 hours. All right, so we're gonna bring it back down and we're gonna turn it into hours. So minutes to hours, there's 60 minutes in an hour, so you divide the minutes by 60 in order to get hours. Pull up your calculator, divide by 60 again, and we're gonna get 1,944 and a half, so like 1,945 roughly hours. Again, I have no idea how long that is. I might tell somebody, hey, it's 2 hours, 3 hours, 8 hours, 10 hours, but I'm never really going to tell someone, yeah, it's roughly 2,000 hours. It doesn't make sense. So we're going to convert it to days. So pull up your calculator again. There's 24 hours in a day. So we'll take this number, we'll divide it by 24, and we get 81 days. All right, so I guess I can just copy paste that so I don't have to worry about changing the color. And then it was 81 days, 0.01, so we'll just leave it at 81. All right, so now let's think about this. Is that a reasonable number of days, or should we convert it to years? All right, if I told you, hey, I'll see you 81 days from now, you could kind of figure it out. If I told you, hey, I'll see you in 0.2 years, that would also sound weird. So maybe the best thing to do here is to convert it to months. All right, so how many days are in a month? It could be 28 if it's this month. It could be 30. It could be 31. Let's stick with 30. It's just an easier number to work with. All right, so we have 81 divided by 30. 2.7. 2.7 months. Let's just call it 3, you know? Something might happen. You might need to make a little maneuver in space and slow down and speed up and do something. So 81 days is roughly 3 months. And if you guys are rounding differently than me, that's okay. We're going to get roughly the same answers anyways. So I'm okay with you guys having different stuff. But if you just want to follow along with what I'm doing, that's totally okay. And that's one problem done. So now we know how long will it take to reach Mars? About 3 months from liftoff to touchdown, right? And actually, if you think about it, it would have to be more than what we say for 2.7, right? Because that was if we were leaving Earth's orbit at 7 miles per hour, didn't slow down the whole way. We talked about making some different maneuvers, but do we want to hit Mars's surface at 7 miles per second? I think you'd probably die, right? So you'd need to slow down in order to land properly and not just like kill everyone, right? So you have to slow down at some point. So I'm very comfortable adding a little bit of extra time to that. All right. So now we're going to move on to the next part. And this is about the same length as this one. And again, a lot of it is just going to be conversions. Okay. So how much food do we need to bring? Well, on average, a human needs about 2,000 calories each day, and we have 5 astronauts on board. So we need 5 times that amount. All right, so let's think about that. We'll come down to our math down here already. 2,000 personal calories per day times 5 astronauts. Well, you can do that in your head. 2 times 5 is 10. Just add the zeros at the end. It's 10,000 calories each day. All right. Well, now what food are we going to feed them? Because, every food has a different amount of calories in it. So, well, eggs are small and they've got a ton of protein and fats and good nutrients for you. So maybe we'll feed them eggs. All right. So eggs are often touted as a superfood. How many eggs would we need to feed all 5 astronauts? One whole large chicken egg has about 70 calories in it. We're going to need all that information. All right. So we have the 10,000 total daily calories, right? That's what we just solved on this line. All right, divided by 70 calories per egg. Now, what are we solving here? We're finding the total eggs per day, which makes sense, right? So 10,000 divided by 70. 142.8. Well, can't really bring 0.8 out of an egg, so 143 eggs per day. It's a heck of a lot of eggs. All right, so if we need 143 eggs per day, and we're spending 81 days on the spaceship, then we need 81 days worth of 143 eggs. So we just multiply those two numbers. So times 81, 11,572, even though it's a 4, we're rounding up because we need that many eggs. And I already forget the number, 11,572. Total eggs for the trip. So nearly 12,000 eggs. I don't know about you, but that's going to take a lot of storage space. Okay? So what if we did something with more calories in it? Like eggs are, pretty, there's 70 calories in just this little tiny unit. But pizza, we all know you eat a pizza, you're going to feel full for a while. You got all the calories you need. All right? So here's something you probably didn't know. One large pepperoni pizza has more than your total daily calorie requirements. All right. So we're going to need less than 5 pizzas per day if that's all you ate. All right. So let's do our math again. 2,000 personal calories, 5 astronauts, it'll be 10,000 total daily calories. All right. Great. So then we move that number back down here. And we divide that by our 2,600. Okay. So pull up your calculator. 10,000 daily calories divided by 2,600 calories per pizza, and we're going to get 3.8 pizzas per day. So we have to round that to 4. Remember, you can't bring just part of a pizza. You have to bring the whole thing. All right? So now if we have 4 total pizzas per day, remember to change the color on your text. And we have 81 days aboard the spaceship. Again, I'm forgetting to change the color on my text. Then we have to multiply those. So 4 times 81, 324. All right. So regardless of what you would rather eat, what would be easier to bring? Right? Like 12,000 eggs or 320 pizzas. That's a huge difference in storage and, all that fun stuff. Okay? That said, who wants to eat pizza for 81 days straight? Who wants to eat eggs for, 81 days straight? It's realistically going to be somewhere in between. You might bring some eggs, some pizza, some bread, some peanut butter, some whatever. But like we said earlier, most of it's probably going to be freeze dried since they're in space. All right? But it does give us a high and low end for the volume of food they have to bring along in order to survive. All right? So that's it for today, guys. I just wanted to show you, how much food you might need to be bringing along and how long it's going to take to get there, how long they have to deal with just being the only 5 people up there, which actually now that we've had quarantine, we know more what it's like to be an astronaut than most of us did before, right? We were just stuck in this small confined space with 1, 2, 3, 4, 5 other people in the house, and that's it. You didn't leave, you didn't do anything else, you were just stuck there with them. You maybe had your own room if you were lucky, but yeah. So that's all I had for you guys today, and I hope that you enjoyed seeing this, and if not, hopefully the discussion on Monday or Tuesday will be good enough to make up for it. I'll see you guys later.